Hello, Tampa Fire Rescue, driver engineer Matt Russell coming to you from Station 6A. Talk to you today about carbon monoxide, or CO for short. Carbon monoxide is a very deadly gas, mainly because of its toxicity. Does it displace oxygen? Yes. Is it flammable at a high enough concentration? Yes. But for the most part, even at low level concentrations, we have a great amount of toxicity associated with this gas. So carbon monoxide is the byproduct of incomplete combustion of any material containing carbon. Could be a possible source of a gas appliance with an ineffective pilot light. Could be a gas vehicle engine, maybe a lawnmower or a car running inside a garage. Maybe a generator that isn't vented or exhausted properly. Or even a fireplace. In fact, something as small as a cigarette produces carbon monoxide. So how do you detect it? Well, it's invisible, it is tasteless, and it's odorless. You need some sort of electronic detection device. Now, we were fortunate enough recently to have all of our truck companies on Tampa Fire outfitted with gas meters that do in fact detect carbon monoxide. So let's cover the procedures on CO responses from alarms or other suspicion to suspect CO, like for instance, the symptoms that our patients might exhibit. Captain Rocha, what are some of the signs and symptoms our patients might exhibit on a CO alarm?
Well, some signs and symptoms may include headache, dizziness, shortness of breath, nausea, vomiting, altered mental status, and even chest pain.
That sounds kind of like alarms we might go on for generalized weakness, maybe a syncopal episode.
Correct. And we don't often think about that, but we should, in the back of our minds, think as we approach scene safety, is it a possibility that we are in a toxic atmosphere or in a carbon monoxide atmosphere?
Absolutely. In fact, carbon monoxide accounts for 400 deaths a year and is the most common poisoning in the U.S., with 20,000 people going to the ER with carbon monoxide poisoning every year in the U.S. It's a very dangerous and toxic gas. When you are talking about a carbon monoxide alarm, we need to think about evacuation, getting any people and animals out of the structure, not just the residents that's being affected. If it's a multi-dwelling unit like an apartment building, we need to evacuate that whole apartment building. Possibly a garage that is shared by all the units with walls. That carbon monoxide can get through those walls, through crawl spaces, through the smallest crack, and start to affect the other units. Let's talk about exactly how toxic carbon monoxide is at certain levels. Our meters register in parts per million. At 4,000 parts per million, you have a risk of rapid death. However, at lower concentrations, you can still be affected by carbon monoxide. If you're exposed to 1,200 parts per million for about 1 hour, you're still at risk for death. And in fact, 1,200 parts per million would be considered our IDLH. What does that mean? Well, it doesn't mean that you drop dead right away, but it's immediate danger to life and health because you lose the ability to make rational decisions and to self-evacuate. It could affect your ability to remove yourself from the environment. That's at 1,200 parts per million. Even a few hours in the low 100s will cause initial symptoms. That's 100 parts per million, very small amount. So you may be wondering, at what point should I be wearing my SCBA? Captain, you got anything to say about that?
Matt, according to our NIOSH pocket guide, we want to wear our SCBAs in an atmosphere where we're getting a reading of 350 parts per million of carbon monoxide in the air.
The vapor density of carbon monoxide is very similar to that of air, which means that it can harmoniously mix together with air, thus you can find it anywhere in the structure that there's air. So, Captain, what does that tell us about how we should go about metering a structure?
So outside, we want to take a baseline reading of the atmosphere. As we're making entry, we want to stop at the doorway and take our second reading. We want to begin metering at the high level, medium, and low, stopping at each point just long enough for the meter to take an accurate reading.
So clipping the meter to your belt and just walking around wouldn't give you adequate readings of carbon monoxide, correct?
Correct.
So essentially we're trying to find the source so we can mitigate the problem. With a carbon monoxide emergency, let's see what our SOGs say about how we should first respond. Captain Rocha?
Well, Matt, first we want to make sure all the residents and their pets are removed from the home. We want to ensure that our personnel are properly protected until safe CO levels are detected. We want to leave all windows and doors open or closed just as they were found before beginning our investigation.
Okay. So a little bit different from if a house was, say, full of smoke from a cooking fire, or if we're ventilating a structure for some other gas reason. In order to identify the source, we might need those high levels that won't affect the building, so evacuate the structure. Leave the doors and windows like you found them. So in conclusion, I'm driver engineer Matt Russell.
And I'm Captain Mario Rocha.
And we're coming to you from Station 6. We want you to know that if you have any questions in the future concerning hazmat topics, we'd be glad to field them. We also welcome any ideas for future training videos. Y'all have a good one and be safe.